Hi, folks. Thanks for joining in. So while you've been waiting for the election results, so hopefully, like some of you might have voted yesterday and having a long night. And also, I guess all of you are doing great, and most importantly, staying safe. I'm Prabhas Srivardhana from WSO2, and this is our 34th Silicon Valley IAM meetup. Today, we have Torsten, and he's going to talk about what's new in OAuth 2.1. Torsten is a CTO at yes.com and also an OAuth, an author of the OAuth 2.1 specification. Also, he has authored and contributed to multiple other identity standards as well. So with that, I'll hand over to Torsten. Over to you.
Thank you much. Thank you very much, Prabhat. Hello from my side as well. My name is Torsten Lodderstedt, and I mean, Prabhat nearly already did my introduction, but I just want to let you know a bit about me. So I'm both an identity practitioner and a standardization guy. So from a practitioner's perspective, I'm in the identity space now for I think 13 years. First of all, I run the consumer identity management with Deutsche Telekom in Germany, where we used OAuth quite heavily for protecting our third-party APIs and providing secure access for our mobile applications. So we adopted OAuth 2.0 in 2012 and had security token-based mechanisms in place since 2007. And now I'm the CTO of yes.com, which is a open banking ecosystem. We help financial institutions to become identity provider and to leverage their internal capabilities in terms of identity, account information, and payment towards third parties. And all our technical designs are heavily based on open standards, especially OAuth 2 and OpenID Connect. And in the standardization side, I joined the identity standardization community early 2010 when the work towards OAuth 2.0 just had begun. And around that time, I contributed to the security analysis of the protocol, and I was the editor of the security threat model and security considerations that in the end were the underpinning of the security considerations in the core spec. And I continue to contribute to that space in OAuth and OpenID Connect. And right now I'm working on a couple of different drafts. You can see them on the bottom of the slide. And most notably for this session today, I'm one of the co-authors of OAuth 2.1. So let's quickly recap what OAuth is. It's the standard for API access authorization. The initial use case when OAuth 2.0 was specified was quite simple. There was the user, and she had some resources with a service provider, in our case here with the Google Photo service. And she wants to use those resources with a third-party application, and she wants to do so without revealing their password or other credentials to that client. So OAuth allows this client to obtain access via so-called access tokens. And the flow that is typically used these days is the authorization code grant. I quite quickly go through the protocol because it's important to understand in order to get the differences that you will see and experience in OAuth 2.1. So if she is accessing the photo editor, she tells the photo editor, well, my photos are stored with Google. And then the photo service redirects her to Google, where she is authenticated and authorizes the access for the photo editor, which in turn materializes in a so-called authorization code, which in turn is exchanged for an access token that is in use for subsequent accesses to the API. That's it. It's simple, isn't it? But OAuth is much broader. OAuth is a universe today. So in the beginning, we had 3 RFCs. The 2 core RFCs that describe how to get an access token and how to use an access token. And as a complementary spec, we had the security threat analysis and considerations. all of those RFCs were published in 2012. And then a lot of other specs arose for new scenarios, new channels, new use cases. And I think that's great because it illustrates that OAuth is used in the wild. And that's something one cannot say for any kind of open standard. OAuth is really successful. OAuth 2 is really successful. And OAuth is really versatile. So we see usages of OAuth today with devices with limited input capabilities in IoT scenarios and so on. And it works because it's got a very powerful extensibility framework that works, namely grant types, for example. And there is an active and very agile community that maintains the standard and further develops the standard. But on the other hand, well, some of those extensions just patch gaps. Pixie, for example, the proof key for code exchange, just patches the fact that in some scenarios, an attacker could hijack a certain authorization transaction. And due to those different specifications and best current practice and so on, the OAuth universe is really hard to understand. And I don't think there are two implementations that really are interoperable on a really byte level, right? And that's really bad. And additionally, since OAuth was is so successful, it's also used beyond its original scope. So originally it was more used in the social sharing scenarios. Nowadays, it's also used for open banking, electronic signing, and a lot of other scenarios that have much higher security requirements than the original requirements. And they are much more dynamic in nature. So for example, in the European Union, we have this Payment Service Directive 2 that obliges every bank to expose APIs that allow customers to use their account information and to initiate payments with licensed third parties, which technically means we will see over the course of the time 6,000 different OAuth authorization servers and the respective APIs. This is really huge. And clearly, interoperability is the key for this to really succeed. So because we have seen these new scenarios, these new use cases, and also due to technology changes, we have seen new attack angles. And this caused even more extension to OAuth to start to exist, namely mutual TLS for OAuth and JAR and resource indicators and so on. So quite a lot of stuff. And it also caused the definition of sector-specific profiles. Most notably, OpenID Foundation's financial grade API profile, which is a higher security profile for OAuth, and it's being used in the open banking space and other spaces as well. So what did we do as a community? We started to work towards new OAuth 2.0 security best current practice. I also typically call them the new OAuth security guidelines. And it's been a long way because we started to work on those back in 2016, late 2015, early 2016 was quite a tremendous effort. And we updated the security threat model and security considerations and came up with new recommendation. For example, and I assume you already heard about that, the BCP now discourages use of the implicit grant, and it also discourages use of the resource owner password credential. I will touch or will describe the rationale for that later on. It also requires exact redirect URI matching, something that was largely underspecified in OAuth 2. And it also recommends the use of sender constraint to access tokens instead of bearer tokens. And a lot of those recommendations are normative changes. And from a procedure perspective, we cannot really define normative changes to a IETF RFC in a best current practice. And that's why we needed to find a solution, and the solution is OAuth 2.1. The idea came up in the last IETF meeting where we met in person. You remember that time before COVID? And we decided, we as a working group decided it's time to really come up with a clean new starting point for developers and we will call that OAuth 2.1. Since it's just a minor release, we will not include any new mechanism. So for example, TLS-based client authentication and sender constrained access tokens, but we only use existing and battle-proven stuff because we just want to clean up the OAuth 2.0 specification. This new OAuth 2.1 specification shall be aligned with the security BCP. And we also use the opportunity to merge the two different core specifications, RFC 6749 and 50, into a single spec. Because content-wise, it doesn't make sense to split them. This is just part of the long history of the OAuth working group. And we merge in existing best current practice for native apps and SPAs. And additionally, in order to make not only to reduce the number of documents, but also give guideline to developers, we also reference or refer to new complementary specs from the core spec. So for example, there is a recommendation to take a look into the MTLS for OAuth, for example. And I can say that the OAuth working group decided to adopt this draft as a working group draft. Just to illustrate how the process works with IETF, first of all, you always start with an individual draft. So as an individual, as a group of people, you write something, you propose that to a working group, and then the working group has to adopt that topic and say, yeah, that's something we wanna work on. And this is already kind of an endorsement that the working group will pursue that activity. So the OAuth working group is fully committed to pursue OAuth 2.1. Yeah. All right, Prabhat, shall we take some questions?
Yes, so one question we have, so both the OAuth 2.0 and 2.1 specifications, while introducing, like probably the first sentence, it says OAuth 2.1 authorization framework enables a third-party application to obtain limited access to an HTTP service. What we have seen is the resource being accessed not just over HTTP, like OAuth being used over MQTT, HTTP2, like gRPC, then to secure Kafka resources like Kafka topics. Any reason, like have you like discussed this with the OAuth working group, whether you change this from HTTP to other services too, or you have any specific reason to keep going with the HTTP service?
That's an excellent question. We briefly touched on that, but we haven't really fully discussed it yet. I think there is no particular reason to limit use of OAuth 2.1 to HTTPS. I think what we want to make sure is that HTTPS is used in favor of HTTP. I think we can agree on that. But we will definitely need to discuss whether other transports are at least mentioned, because obviously OAuth access tokens can be used via any secure transport. Yeah. I will take a note and bring that to the working group's attention.
Basically, what I saw is in OAuth 2.0, you delegate that to, like, you refer this bearer token usage RFC. Now I think we have removed the reference to that and specifically highlight this is how you use this with HTTP 1.1. So probably if we can make that an extension, for example, with HTTP2, with gRPC, we use metadata to send these headers, the bearer header. Mm-hmm. And so people have used their custom ones, right? So with Kafka, they use their own headers. So it's better like if we can build an extension mechanism on how you can transport this token to a resource.
Yeah, I mean, I would like to invite the people that are interested in to add that these topics are being added to the OAuth 2.1 specification to turn up on the mailing list and make a proposal. I mean, this is how IETF works, right? Yeah, if you have a use case and you can convince the working group to include that in the specification, we are more than happy to include that. But we also need the expertise, right? So I don't have any expertise with Kafka or MQT. So I don't feel I should really propose text how to include that, because that will go wrong, terribly go wrong.
Sure, yeah. So that's all we have for now. Maybe we can proceed there.
Thank you, and thank you for the question. All right, let's dig into the normative changes in detail. So I first will give you an overview on the normative changes, and then we'll drill down into some of those topics. So first of all, the implicit grant is omitted, which technically means response type token. We only have a response type code in the spec. The resource owner password credential is being omitted. And the authorization code flow is hardened because it also had some issues and now must be used in conjunction with proof key for code exchange to prevent or detect code replay. And it is also must be used in conjunction with exact redirect UI matching in order to prevent code leakage. I will describe this in more detail in the coming slides. Also, we omit the option for bearer tokens to be sent in the query string of a URI. The main reason being because if you put an access token in a URI and send a GET request, it will end up in caches, log files, referrer header, and someplace else. So this is a countermeasure against token leakage.
Torsten, sorry. On the implicit grant type, so once you, so in OpenID Connect, it is using implicit authentication flow, which has a reference to the implicit grant type section of OAuth 2.0 spec, which talks about how to validate an access token. So how do you see moving forward, like OpenID Connect spec implicit flow going to evolve with the OAuth 2.1?
I can give you my personal opinion on that, even though I'm a member of the OpenID Connect working group. We haven't really discussed this topic yet. What we have done is in the financial grade API working group, we decided to remove all response types that expose the token in the front channel from the profile. And I think that serves as a pattern of how OpenID Connect could evolve, which in the end would leave us with code and code ID token and ID token, I guess. But that's just my personal opinion. I would like to postpone that discussion a bit because I will talk in depth about the implicit grant and why we decided to omit the implicit grant, because that's a very, very important topic. A lot of people use implicit grant for their spas and so on. So I would like to explain in detail what the alternative is that we recommend now.
Sure, yeah. And also if you can explain at that point, like implicit, the authentication flow in OpenID Connect fixes some of the key security issues that we highlight in implicit grant type using this ID token, AT hash, those stuff, right? If you can do a comparison with that too, would be great.
First of all, I would like to focus on OAuth.
Yeah.
Okay. And if there is anything left to be answered, then let's discuss it afterwards. I want to keep it simple because OAuth 2.1 is really, really simple. And it serves as a foundation for a lot of use cases. So,
there's another
all right.
Can I ask that too? Does the spec say anything about putting the token in the fragment rather than the query string? This is from Alan Karp.
Which spec? The OAuth 2.1 spec?
Does the spec say anything about putting token in fragment? I think this will go away, right, with removing the implicit grant type.
RFC's 6749 always only supported fragment in conjunction with the response type ID token.
Yeah.
So there is no mechanism in OAuth to convey a code in a fragment. I mean, you can basically do that, but not within the scope of OAuth 2.1.
Yeah. So that's all. Yeah.
Okay, good. Refresh tokens for public clients must be sender constrained or rotating. This is basically not really a new topic. That was already covered in the original RFC. where the text said that the refresh tokens for public clients shall be rotated, and for confidential client authentication must be used. But due to the rise of new mechanisms that allow to also attach or link a refresh token for a public client with, for example, public key certificates, we emphasize this topic because we now have a new mechanism and additional mechanism, which is much easier to handle than refresh token rotation for protecting refresh tokens. And since the refresh tokens play a very important role for refreshing access tokens in conjunction with the OAuth code flow, that's one of the additional key mechanisms in the OAuth 2.1 spec. All right, let's do a deep dive into the issues that we have with the implicit grant. So first of all, access tokens may leak through browser history, referral headers, and so on. So that's a fact. If you send the access tokens through the front channel. There's also a lack of access token replay protection, since the way the implicit grant is built does not allow you yet to somehow associate a access token with a proof key, for example, that you can use to cope with access token replay. And this is not a security issue, but a technical issue that we all are facing or face, that the refresh of an access token via the implicit grant using hidden redirects on iframe, for example, is nowadays blocked by browsers due to the third-party cookie policy. And well, when it comes to the security of those access tokens, the question is this a new topic? I doubt so. If you take a closer look on RFC 6749 security considerations section, you will see that we were aware of the risks of the implicit grant when OAuth 2.0 was published. So the fact that the implicit grant exposes the access token to unauthorized parties, and also that in the case of the implicit flow, an attacker can switch, replay, and replay tokens, was clear, even though there was a strong support for having that implicit grant, just because at that time there was no other way to support JavaScript based applications we nowadays call spas. And that's basically the reason why the implicit grant was introduced beside the code flow in RFC 6749. But thanks to cross origin resource sharing CORS, this limitation no longer exists. So this means that applications can use the authorization code grant type as the standard grant type for all kinds of user interaction, even for spas and other applications running in the browser. So there is no longer a need for that. We see the security issues that we have, and referring back to your comment, Prabhat, regarding what OIDC does to prevent this countermeasures. OIDC can help to detect replay of an access token in a different transaction if you use the response type ID token and bind the access token via IT hash and the nonce to this transaction. That works, but there is no countermeasure against access token leakage, and there is no mechanism to equip those access tokens with a mechanism for replay detection towards resource servers. And if you sum up all those issues and the technical limitations, I personally don't see a need to have an additional grant, because that also contributes to the confusion for developers. You've got two redirect-based flows. Which one to choose for what application? And the answer now is simple: use code in all situations that require user interaction. And if you want to refresh, use refresh tokens. The resource owner password grant is the second grant that we omitted from the spec. It also has had some issues. First of all, is obvious, that it exposes the credentials of the user to the client. And this increases the attack surface because there are more places where the credentials of the user are being processed, which also means there are more places where they can leak. And it also trains user to enter their credentials in various places, which is also not a good practice. And what was not that clear at the beginning when we worked on OAuth 2.0 is the resource password credential could be extended to support multi-factor authentication. We did that once at Deutsche Telekom, but it's really, really complex and is really, proprietary because every multi-factor authentication method works differently. So this is something we do not want to pursue. And basically, the resource owner password credential doesn't work with SSO, which is really, really bad. And just as a note, why was the resource owner password grant ever included in the specification? Well, it was because to support the migration of pre-OAuth 2 solutions towards OAuth 2. And I mean, this is now 8 years ago, and we think it's time to abandon that feature. All right, Prabhat, you asked me to take further questions.
Yeah,
I'm
so
open.
There's a comment, probably a question too, from Dexter. I think one cause of confusion is that OpenID Connect core specifies the implicit grant, and FAPI goes even further by adding the hybrid grant, even though BCP 4.2 has been recommending against implicit. Also seeing fragment hacked with JavaScript a lot, which defeats the purpose. So removal makes a lot of sense to me. So I think it's a comment on removing the implicit grant type.
Yeah, thank you. I would like to add that FAPI now is also cleaned up significantly. FAPI, the FAPI read-write profile only supports code and code ID token. So we have seen a convergence between the security BCP and the financial grade API profile. And in the upcoming FAPI 2 security profile, especially the baseline profile, we will recommend the code basically for all kinds of OAuth authorization transaction.
So there's another question from John Peters, not very clear, why he says rotating equals one-time use. Probably this is related to the refresh tokens.
I think so. I think so, yeah. Rotating means one-time use. Thanks for the question. So basically what it means is when you use the refresh token to get a new access token, with that new access token, you get another refresh token. And this is not only one-time use, it goes beyond that, because just issuing a new refresh token doesn't help that much if the refresh token, the new refresh token, is issued to the attacker. So if an attacker is able to get access to your refresh token and uses that to get a new access token, it would effectively take over your session and can mint new access token at will. The mechanism really works if both the legit client and the attacker both try to refresh, and the AS detects that someone is trying to use an expired refresh token to refresh an access token. And it doesn't matter whether the attacker is the party that sends the expired refresh token or whether it's a legit client. One of them will. And in that case, the AS needs to revoke the underlying grant along with all the refresh tokens. Then rotating refresh token works perfectly. I would also like to point out that implementing refresh token rotation is a bit complex and requires synchronized database access and so on and so on. So it can be a bit problematic for a high scalability, and that's why I think that other options should be considered, such as sender constrained refresh tokens. There are two specifications out there that can help. One is mutual TLS for OAuth 2, which allows to bind the refresh token to a TLS client certificate. And the other one is DPOP, which is I would say the application level equivalent to mutual TLS, which allows to bind the refresh token to a certain public key.
Yeah, so there's another question from Never Seen. So he asked, my new assignment is to implement decoupled approach to our PSD2 API by pushing a message to mobile application to authenticate user. Is it CIBA flow right path?
So first of all, hi, Nevesin. Can you repeat the question again? I didn't get it. So Nevesin wants to implement a decoupled flow?
Decoupled approach to our PSD2 API by pushing message to mobile application to authenticate user. Is it CIBA flow the right path?
Which flow?
CIBA.
CIB, what's that?
It's
oh, CIBA.
CIBA.
Oh, yeah. CIBA. Okay. yeah, exactly. Yeah. Sorry, I was a bit confused. Yeah. CIBA. I think CIBA is the right way to go for this kind of topic because it sits on top of OAuth and allows just to give a wider explanation. So CIBA is utilizing the extension model of OAuth and establishes a new flow where the relying party or the client can send a request to the authorization server, and the authorization server then out of band reaches out to the user in order to get the confirmation of that user for the authorization request. So this is using the extensibility model of OAuth in a quite interesting and nice way, and allows to implement use cases where, for example, the user calls your call center, wants to authorize something, but also if you have you want to use flows on different devices.
Last question for this session. So Lawrence asking, any software test tools that can be used to verify and validate 2.1?
Excellent question. Right now, there is no automatic test to test conformance with OAuth 2.1. Honestly speaking, I don't know whether we really will reach that point, because so far OAuth was always treated as a framework. So there wasn't even the intention to be really bit level interoperable, which would be the prerequisite for really running conformance tests. But it's a very good question. I mean, if you want, please raise that on the mailing list. I will take note. What I can tell you is that the FAPI profile, which is based on OAuth and also incorporates already in its FAPI 2 incarnation elements of OAuth 2.1, will definitely see conformance tests, because it further limits the way certain mechanisms are being used, which makes it much easier to really conformance test.
Yeah, let's take one more question. So Chidanand asking, some clients like IE11 only support implicit flow, I guess for SPA. How do you address these with Pixie?
I don't know. I don't fully get the relationship between implicit and Pixie, because
if you're using implicit flow, how do you address what is being addressed with Pixie? Because Pixie is not designed for the implicit flow, right?
That's correct. I mean, in the end, Pixie, and I will show that in the next slide, how Pixie works. Pixie utilizes the fact, or leverages the fact, that in the code flow, there is a further interaction between the client and the AS via the token request. And since this token request does not exist in the implicit flow, all bets are off. So you can't really protect the implicit flow in the way you can protect the code flow. It's one further reasons why we want to go with code, because code has more potential for advanced security measures.
Yeah. I think we can move forward.
Okay, good. So the authorization code grant type now is the standard grant type for all flows with user involvement, but even the authorization code had issues. Just to name a few, code leakage via open redirection, lack of code replay prevention. This has been discovered as part of a scientific research and analysis of OAuth and OpenID Connect, along with the mix-up attack. The mix-up attack means that when a client is connected to multiple ASs, an attacker could confuse the client so it thinks it's calling a certain AS, but in reality it's calling to another AS, and then hence the code that was issued by that AS to another AS that is provided by the attacker. So in that way, an attacker can get hold of access tokens or codes and then utilize that to impersonate the victim. The mitigations that were defined already in the security BCP and are now being added to OAuth 2.1 are the use of PXE as a transaction-specific secret which binds the authorization request to a certain user agent. So only if the secret that was used initially to start the authorization request is used also to exchange the code, the client knows, well, everything is fine. This code was issued on the same device where I started the authorization request. If an attacker uses the code someplace else and it does not have access to the PXE challenge and verifier, it can't present the secret along with the code, so it cannot really redeem the code. That's a quite effective measure. PXE itself, as the name suggests, proof key for code exchange by OAuth public clients, was initially defined for protecting public clients from being impersonated, especially on smartphone platforms. And when we did the security analysis of the security BCP, we realized we need a mechanism for general code injection prevention. And we discussed certain alternatives, including using the nonce as defined in OpenID Connect and also specifying a new facility. But then we came to the conclusion, PXE is widely used and we have collected good experiences. We would we increase the scope of that, and now it's being a must for all kinds of clients, not only public clients. All kinds of clients must use PXE. There is an exception in the OAuth 2.1 spec. Clients, confidential clients that use OpenID Connect nonce can keep using OpenID Connect along with nonce because it provides an equivalent protection. OIDC clients, public OIDC clients that use nonce should move towards PXE because nonce and public clients doesn't work as well as PXE. Then there is the exact redirect UI matching. Before we started the video broadcast, Prabhat and I talked about this redirect UI matching. And what you can see in the wild today is that people use regular expressions to define a set of redirect UIs that are alleged redirect UIs for a certain client. That is really very convenient, but it poses a lot of challenges. So, and if you do not get your regular expressions right, there are a lot of ways an attacker could utilize those. If you want to know more about that, please give the security BCP a read. We explain the different attack angles in detail there. The bottom line is we adopted the approach that OpenID Connect already introduced, which is exact redirect UI matching. This might lead to more administrative effort. I know that. I've been responsible for identity management systems for more than a decade. But in the end, if you use regular expressions, that's really a dangerous way. I would rather go a different way, which I will talk about in the second part of the presentation. Yeah, and mix-up detection is provided either by AS-specific redirect UIs or by a new issuer response parameter that we are discussing right now in the working group, because that is a very easy to add and support mechanism that could also be used by the client to determine who actually did the authorization. Well, and additionally, code, as I said, has a lot of potential for advanced countermeasures. One of them is if you use code, you can also link the access token and the refresh token that are being issued to proof keys. So you can link them to certificates, you can link them to your public private key pair, and so on. Those mechanisms are defined in other specs, but you can use them on top of OAuth 2.1 to further improve the security of your system. Let's take another look on the improved authorization code grant type. So that's the flow as you have seen it before. And the first addition is this code challenge parameter. The code challenge parameter is the hash of the secret that the client created to protect this authorization transaction to bind it to a user agent. And this is a preparation for detecting replay later in the token request. And also, exact reader UI matching kicks in at exactly that point in the flow. The second one is mix-up detection. The mix-up detection, as I said, either works by using a specific redirect URI. So the client needs to memorize what AS it believes it sent the authorization request to. And when the redirect hits the client again, it compares where did the redirect land, what did I expect, and if there is a conflict, it shall abort the transaction. And then in the code request, we send the code verifier, which is the secret itself, not the hash, that was sent in the authorization request, and the AS then will check whether the code and the verifier match each other. If they do not match, the AS will refuse to create a token and will respond with an error message. So this is also a nice feature of PXE because the security check is placed with the AS. It's implemented once and works for all clients. So not every client implementer needs to really understand and implement all the security checks that are needed to cope with this kind of attack. And then we have the one-time use for codes. So if for whatever reason a code is leaked and replayed in a different place, even with PXE, the AS should detect that and revoke the tokens that were replaced, that were issued. All right, Prabhat, we can take further questions.
Yes, so there's a question, a comment from James Kemp. Might be a good idea to start a certification group like Wi-Fi Alliance for 802.11 implementations might help to prevent the kind of incompatibility issues that came up with OAuth 2. So that's a comment. Do you have anything to say? Good.
Yeah, I agree. I agree. I would really love to see this kind of interoperability testing. We will see that for OAuth for GNAP, most likely, but the protocol must also be specified on a level that allows to really test for interoperability. We will see whether we will reach that level in OAuth 2.1.
Yeah, so I have a question on how the PXE was introduced to OAuth 2.1. Would like to know like the reason behind that, like the background. So in OAuth 2.1 spec, I see some of the parameters like code challenge method, code verifier being redefined in the OAuth 2.1 spec itself rather than pointing to the PXE RFC. Is that done on purpose?
Yeah, sure. It's done on purpose because it's now really part of the core spec. So we decided to not depend or refer to another RFC, but to incorporate that in the core specification, because in the future there won't be a authorization request under OAuth 2.1 that does not use PXE. So from our perspective, it made sense to merge that in. I should have mentioned that in the introduction. Yeah, I forgot that. Thank you for pointing out.
There's another one from Dexter. Previously, I've heard that PXE is not required in communications that already involve asymmetric encryption, example, authentication methods like MTLS or private key JWT. Will this be the case in 2.1? I guess the client assertion is equivalent in some ways.
I have to admit, I don't fully understand the comparison, because code is not a mechanism. PXE is not a mechanism to protect the integrity or the confidentiality of the message. PXE is used as I said, as a one-time nonce to bind the authorization transaction to a certain user agent. So I don't think a signed assertion or a signed request could do the same.
So I think we can proceed.
But you can at any time drop me an email and we can discuss that offline.
Sure, yeah.
Okay. Oh, I forgot the last point. So if you have a higher security scenario where you want to prevent access token leakage in a replay, you might want to use MTLS or DPoP to protect your access tokens. So to sum up with OAuth 2.1, we now have the improved OAuth authorization code grant type, which is the standard for any kind of applications with user interaction. Refresh tokens shall be for public clients shall be sender constrained or rotating. I didn't mention the client credential so far. This is just because it remains unchanged and it is recommended for all service-to-service scenarios. And implementers might consider to use sender constrained access tokens. We did not put any mechanism for really constraining the sender of an access token into the 2.1 spec because of the high-level requirement to only use existing stuff that is really battle-proven for years. MTLS is an RFC for, I think, a year now. It's used in the wild. So one might consider to include that in a future version. But DPoP, for example, is still a working group draft, so it's not an RFC yet. Are there other features? Otherwise, I will.
Yeah, maybe we can take a couple of questions.
Yeah.
So one question, like if you can clarify more on the type of client. So the 2.1 introduced a new client type called credentialed, right? Can you give some examples like how the credential clients are different from credentialed clients?
That's a very good question. In the beginning with OAuth 2.0, the assumption was that every client that has a credential also has gone through some kind of wedding identity verification process, because those clients are typically set up in advance. With the advent of dynamic client registration, this assumption just no longer holds true. So that's why we decided to really split it up, and the draft also explains that. So basically, a credential client is just a client with a credential, which basically means you can recognize that client if it returns to your AS, and it can authenticate, yes, I'm the same client as last time. So in the user identity world, you would say that's the difference between authentication and identification. So for a credentialed client or a credentialed user, you can recognize that user or that client, but you don't really know who this client or user is. Whereas for a confidential client, the assumption is it is a client that DS somehow verified. So it knows, for example, what organization, what developer is behind that client. And this client also has credentials, because otherwise it could not really prove that the calling party is really that client. So that means we split the confidential client as it exists in OAuth 2.0 into different categories. the confidential client, which has credentials and is identified, and the credentialed client that just has a credential but is not identified. Typically, a client that uses dynamic client registration, for example, to establish a secret, but the AS does not really know who is behind that client.
Yeah. So there's another question from Alan. Does OAuth 2.1 have a mechanism for subscope redelegation?
Subscope redelegation. Could you please elaborate on what that means?
I guess this is quite similar to us. The RFC we have right now for this token exchange. You can exchange a token to a subscope access token, right? You get an access token and you can exchange it to a new access token with the subscope. So probably is asking questions about that.
Yeah, I think I understand. So basically, if I get it right, you wanna have a grant for 3 different scopes, and you wanna obtain an access token which is good for one of those scopes, for example. This can basically be done with OAuth 2 already, even though I think we are in a zone where we are going beyond the boundaries of OAuth 2. There is no change regarding that topic in OAuth 2.1. But there is a new emerging draft that could help with that topic. So baseline, this can be done with OAuth 2. We at Deutsche Telekom already did that. So we had a refresh token that was associated with a powerful grant and then issued different access tokens for different subscopes. That's possible, but it's questionable whether every product supports that. That will definitely be a feature that QNAP will support. And I'm hoping we will introduce that feature in the OAuth 2.x world with the rich authorization request specification that I'm going to talk about in a second.
Yeah, I think you answered this question. Clarifies it. I have a read-write token. Can I get a read-only token while keeping the original? So like you get access token for a bigger scope and you exchange it to a subset of scopes of the original.
Yeah, I would do that with refresh tokens. So you issue a refresh token and then you ask for a subscope in a refresh request. Yeah, that's perfectly possible.
Yeah. Yeah, I think we can proceed.
Okay.
Yeah.
Okay. Very good. All right. There are two emerging features I'm working on right now that I would like to bring to your attention. The first of them is called pushed authorization requests, and this is basically an addition or an extension for OAuth 2 that allows the client to set up the transaction in a backchannel request before the actual user interaction starts. And the second one is called rich authorization request, and this is an addition that allows the client to specify its authorization requirements with a much richer model and syntax than provided by scope values. Both extensions are based on our work in the FAPI working group around open banking. So we analyzed the different patterns that we have seen in the different APIs and then came up with the conclusion there are 2 specific areas where OAuth could be extended to cope with the specific requirements of those use cases. And it turned out that especially pushed authorization request is a feature that got massive adoption and momentum and is really very useful. So we already had this slide twice now. That's the authorization code grant type, the traditional one. With PAR, what changes? Well, before the client redirects the user agent to the AS, it first sends a post request to the AS. Those of you that already know or have used OAuth 1 will immediately recognize, yeah, we already had that in OAuth 1. There was a setup request, and you could use that to pass on tons of data. Yes, now it's back. And why can we do that? Because we no longer have the implicit grant. So there is no need to limit the protocol design for to messages going through the browser. We utilize that. So we send that post request, and this post request contains all the data that in the traditional flow go through the user agent. So they are deposited with the AS, and the AS in turn returns a request URI that contains an identifier of that particular request. And then the client initiates the redirect, which includes the redirect URI and the client ID. That's it. No more data, totally static. And the rest works the same as before. And the nice thing is, it's a really robust solution for passing large amounts of data in authorization request, which is especially important in open banking and other regulated scenarios where you really want to describe all the nitty-gritty details of the authorization request, whether you want to move money, how much money, or if you want to access certain resources. You need plenty of space to pass that data to the AS. PAR is a way to do that. But it also has other benefits that are interesting for other types of clients. Because it significantly improves the security of the OAuth flow. First of all the authorization data are passed via a TLS protected channel, which means they are integrity protected and confidential. And that with just transport security, which comes really cheap in comparison to application level security. And the client can be authenticated before the user interaction starts. This means the AS can authorize the client. And if the client, for example, asks for scopes it is not allowed to ask for, it can just turn down and refuse the request before the user is even bothered, right? So today, it can happen that there is a redirect to the AS, then the AS decides, no, I'm not going to serve that request, and it sends back the redirect. So this is something that disturbs the user experience. That's no longer going to happen. And since we authenticate the client now, we no longer need to rely on the redirect URI to identify the client, because that's one of the purposes why we have the redirect URI in the authorization request. We want to identify, or we want to make sure if that's the client ID, the redirect URI must match to that client ID, so we make sure that the code is not revealed to someplace else. Since we now authenticate the client, we have a much stronger confidence in the identity of the client. We can just get rid of pre-registered redirect URIs. And that's the mechanism I referred to previously. So if you're tired of managing redirect URIs, take a look into PAR. So at least for confidential clients, you can allow clients to dynamically establish the redirect URI for a certain transaction, which makes the management of clients much, much easier. And there are other security benefits. I won't go into those details. And the other mechanism that I would like to explain to you is the rich authorization request. So if you ever hit the wall or the ceiling with what the scope parameter can express. So for example, if you want to authorize access to certain resources in a cloud, if you want to initiate payments, if you whatever, something that is more complex than I want to access to contacts, read, write, then you most likely want to use JSON for describing your authorization requirements. And that is basically what rich authorization request is all about. You can use typed JSON objects to describe what you want to do. In our example on the right-hand side, you see a authorization request for payment initiation. So the client asks the user via the AS whether it is allowed to transfer 123 euro and 50 cents to merchant 123 and further information. And this is then passed in the authorization request in the same way as the scope value is typically passed. And the benefit is it's really flexible, but type safe. You could also even use JSON Schema, for example, to describe your authorization data types. We at yes.com use that, for example, for authorizing access for qualified electronic signatures, which is also a very, very complex transaction. And it allows API-specific JSON object to be designed. So there is no one size fits all. Even though we have common data element, you can design for your API the structure that you need to authorize access. And this is also a way to, in an interoperable way, to issue RS-specific and also downgraded access tokens. Coming back to the question that was raised previously, because raw also contains, and it's shown in this slide, it also allows to specify the client where it's going to use this permission. So using this information, you can also say, I would like to access A, B, C. And when you obtain an access token, you just say, I wanted the access token for location A, potentially downgraded even for read access only. And then the AS can issue the access tokens in an interoperable way, because we're going to specify that into this spec. Well, that's it. I'm open to more questions.
Yes, so we have one question from Alan. Does authenticating the client imply a pre-existing relationship between the client and authorization server or resource server?
I mean, there are two categories of clients, and the policy that you will apply depends on how much confidence you have in the identity of the client. Yes, first of all, it implies there is some relationship indirectly or directly. So if you, for example, use certificates for authentication, you do not even need to have a pre-existing relationship, a direct relationship. You both need to rely on the same third party, so you can establish the trust via that third party. So that's possible as well. But yes, you need to have credentials that the AS trusts in.
There's another question from Dexter. Regarding FAPI open banking, would the raw interaction be a separate request or replacement to the consent management API call that precedes redirecting the user?
I'm not quite sure whether consent call refers to UK Open Banking's consent facility, but if so, you can combine it with OAuth 2.1, or you can, instead of the consent API, use PAR and RAW in conjunction, because they fulfill the same requirements, but in a much more general way. So the consent API was one of the elements of UK Open Banking that we analyzed before we started to work on RAW and PAR.
Okay. So one question, like, is there a need you see like to version a token? Like from the client side, from the application side, I may work with an authorization server which support OAuth 2.0 and another one 2.1. So I get token from different endpoints. What I see is a difference that the client, there's an impact on the client side is the token refreshing. Right? There are two different mechanisms. The two versions refresh the tokens. Do you see there's a need to embed a version to the token, or like at least to the API kind of thing?
That's a very good question. Our fundamental assumption is that the client knows what version of OAuth the AS talks to. So in that scenario, the client would or must be aware of this guy is speaking OAuth 2.0, the other one 2.1, because, for example, if the client with the 2.1 wants to interact with 2.1 AS, it must use code and it must use PXE. So it somehow needs to have different code paths to distinguish that. I think when it comes to issuance of access token and use of access token, OAuth 2.0 and OAuth 2.1 are equivalent.
Yeah, only thing is refresh, the mechanism of refreshing a token.
No, even the refreshing is equivalent, because
what you get returned back can be different. So in 2.0, it can be the same, being refreshed again and again.
Already the RFC 6749 has the functionality for rotating a refresh token. So the token response in RFC 6749 already has that mechanism that you get a refresh token. If you send a refresh token to the token endpoint, you get a new refresh token back. So the mechanics is already there in OAuth 2.0, but not a lot of implementations use that yet.
Yeah, but oh yes, that's true. But 2.1 has made it a mandatory, right? It's a must to do that. Like if we are
no, that's a recommendation. That's a recommendation. So the AES is recommended to use certain measures to protect refresh tokens from being reflayed. This is not a must, as far as I remember.
Okay, so so how about introducing versioning to the at least the authorization server metadata configuration? Any plans on that? Like whether you support version of OAuth you support kind of.
Not yet. My assumption would be that, as I said, that there will be. No, I didn't say that. That even AS that supports different versions, it would use different endpoints. But yes, we could just have a marker in the metadata denoting, okay, this is 2.0. We support 2.0. We should support 2.1. Yeah, there wasn't much discussion around that yet, but I will take note. Yeah.
Sure. I think that's all the questions we have. So thank you very much, Torsten. It was a very informative session, and thanks a lot everyone for joining. And looking forward to meet you again in our next meetup, which will be on HashiCorp Vault. So I'll probably announce the meetup today itself. And thank you again. Thanks a lot for joining.
And thank you very much for the opportunity to be with you today.